Today we are going to talk about percent of change. I know you've worked with this in the past. Remember, the percent of change might represent an increase or a decrease. So for example, I could say that the Bryn Mawr population increased by 25% from the 2011-2012 school year to the 2012-2013 school year. And that would be a positive number. I could also say that something has decreased. Maybe my bank account dropped by 20% after I spent my money on an iPad. So again, we can use percents like that all the time. What we're going to do is calculate those percents of change and identify them as either representing percents of increase or percents of decrease. Let's just go ahead and get the basics down for a moment. So the percent of change is basically a ratio that compares the change in quantity to the original amount. What does that mean? Well, let's explore that. So, to find the percent of change, and initially you will be working with a decimal that you need to convert into a percent. You're writing a ratio that shows the change compared to the original amount. I like to look at it this way to make it a little bit more basic. You know, how do you find that amount of change? Well, you have new information and you have old or original information. So, you calculate your decimal by first finding the amount of change, new info minus old info, comparing it to the old info, and then converting to a percent. If the percent is positive, the percent of change is a percent increase. A percent decrease is represented by a negative percent. The beauty of it is you don't have to worry about whether or not something should or should not have a negative sign. If you do your math correctly, the negative sign will appear on its own and you can clearly see that it's a decrease. Please make sure that you do follow directions. If you're asked to say whether or not a percentage represents an increase or a decrease, please do so. So let's look at an example. So let's find the percent of change from 60 degrees Fahrenheit to 84 degrees Fahrenheit. And then we need to state whether the percent of change is an increase or a decrease. So, first thing we need to do is recognize what's the new information and what's the old information. Well, we're going from 60 degrees to 84 degrees. So, the old info is going to be represented with the number 60. The new info is a nice temperature of 84. When we put this into the formula, remember, we get some decimal equaling the amount of change compared to the old. Let's just substitute our numbers in. So our decimal will be calculated in new 84 minus the original amount, 60, compared to that original amount. You can do 84 minus 60 in your head. You get 24/60ths. Before we make this into a decimal, let's go ahead and simplify first. So 24/60ths, we can divide by 12. Okay, we get 2/5. 2/5 is also equal to 4/10 or 0.4. I can write that down first so you can see it. So there's my decimal. Let's write this as a percentage because that is what we need to find. 40%. It is positive. It makes sense in this case. We are going up from 60 up to 84, so it is a positive increase. And it therefore represents a percent of increase. So this is a percent increase. Okay, let's take a look at something else. One of the largest stock market drops on Wall Street occurred on October 19th, 1987. On that day, the stock market opened at 2,246.74 points. And it closed at 1,738.42 points. There's always a start of day and an end of day, and all of the trading happens in between. So when it says it opened, that is the initial amount of points that we started with, and the close, that's what we ended the day with. So the question is, well, what's the percent of change? Well, we're going from about 2,000 points down to about 1,700 points. So right away, we should be able to recognize whether or not this will be a percent of increase or a percent of decrease. So going from around 2,000 to about 1,700, we should see that we are going down. So this will be a percent of decrease. It's always good just to sit back and logically look at your numbers first, and then we'll go ahead and calculate the percent. So we have our new number. That's what we closed with. Okay, that is the most current, newest number. What we opened with was the original amount. You obviously want to make sure you know what's the original versus what's the new amount, because that will greatly affect your answer. So think about it. What makes sense logically? What's the original amount and what did you end with? What's the newest amount? When we set this up, we need to do new minus old compared to the original amount. You may use a calculator for this. Go ahead and type these numbers in. And you should see that we do get a negative value in the numerator. So let's go ahead and get that down. We get negative 508.32 all over 2,246.74. Now we are not going to spend the time simplifying this by hand. To get the decimal, we can go ahead and do the division. So you may type it into your calculator, negative 508.32 divided by 2,246 and 74 hundredths. And of course we get this long decimal that goes on forever. So that's about equal to, you should get negative 0.02264 ... Just as before, do not round until you've converted your number into a percentage. So we'll go ahead and round to the nearest tenth, but I don't want to do it now, because if I did it now, I'd say that there was a 0% percent of change, and that's not true. So always convert to a percent first. We multiply by 100, we move the decimal over twice, and we will get a negative. Oops, and I do say that I wrote this down incorrectly, so let me just change that for a moment. Thank you. It's negative 0.22624 ... So when I multiply by 100, I move that decimal over twice, and I do get negative 22 point, and if I'm rounding to the nearest tenth, I have a 6 right next to it as a 2. I'm going to keep that as 6%. Okay, so obviously it would not have gone to 0%. If we had rounded to the nearest tenth initially, it would have been 20%. Negative 22.6% is more accurate, so that's why we save our rounding until we have converted to a percentage. That negative sign shows that we do have, in fact, a percent of decrease. Just shows it goes down. Let's talk about markups and discounts. I'm sure this will be a little bit more applicable to you because I know everybody loves a good sale, and it's great when you can spend money and save money at the same time. So let's see how percent of increase might work here. Increase or decrease. So basically, let's talk about some of our terminology. A markup. A store sells items for more than it pays for them, and that's what is called a markup. And this is a percent increase. And again, it's when a store sells an item for more than it paid for it. That makes sense because the store has to make some money. Okay. The selling price of an item is what a customer pays for it. It's what you're paying for. The price you are paying. And a discount, which is lovely, is the amount by which the regular price is reduced. And this is a percent decrease. We all love those 50% off sales, right? Those are easy to calculate in your head, how much you might be spending, but 25% off works as well. Sometimes they'll have 75% off, you never know. Okay, so let's go ahead and work through some examples. Let's find the selling price. If a store pays $42 for a pair of rollerblades and the markup is 25%. So find the selling price if a store pays $42 for a pair of rollerblades and the markup is 25%. So the selling price, that's the price that you're going to pay. The store just bought these rollerblades for $42, but of course they need to make some money, so they're going to sell it for more than $42. And we need to figure out what that selling price is if we know the markup is 25%. There are a couple of different ways we could do this. And some of these ways will look similar to the ways that we worked with percent equation. So let's go ahead and first way, we could find the amount of markup and then add it to the $42. So the first way is to go ahead and find 25% of $42. And you may use the percent proportion or percent equation to do this. I find the percent equation a little bit easier. I can find the part just by doing this multiplication. When we do this, we get 1050. Now, we have to recognize that this represents, the $10.50 represents the markup. We would have to add it to the $42 to find the selling price. So 42 plus 1050, and that gives us a selling price of $52.50. So it's the same kind of thing when we're talking about sales tax, 6% sales tax, except this is the initial markup. If that's what you're paying, you'd have to pay sales tax on top of that. The second method is to find the total percent. So we can find 100% of what the store paid plus the 25% of what the store paid, and do all of our calculations just with one step, because we know we're paying more than that 42, and that's what the 100% covers. So if I do that, I will get the $52.50 right away. Either way works. It doesn't matter to me which method you choose to use, but it's good to know both methods. Please get out page 36 and work through number 5. You may hit pause, and then when you're ready to see the solution, you may hit unpause. Okay, so here we have a record store. It's having a 25% off sale. Find the sale price of a CD that regularly costs $14.99. Again, you could do this a couple of different ways, but here we are discounting, so we're taking money off of the original price. You should come up with a sale price of $11.24. Thank you very much, and I will see you in class tomorrow. Bye.